Hi, today we're going to derive the power rule. First, what is the power rule? The power rule is the derivative of the function x to the n with respect to x. This being equal to nx to the n minus 1. With this rule, we can find the derivative of any polynomial function. So how do we derive the power rule? To do this, we must go to first principles. What is the derivative? The derivative is the slope of the tangent line. How do we find the slope of the tangent line? We need the difference quotient. So we write the derivative of x to the n with respect to x, this being equal to the difference quotient for the limit of delta x approaching 0 being equal to the slope, which is the difference quotient. We write limit delta x approaching 0 f of x plus delta x minus f of x, this being over delta x. This is the slope, this is the y part, and this is the x part, rise over run. As you recall, the function is x to the n, so let's put that in. Derivative of x to the n with respect to x is equal to limit delta x approaching 0, the quantity of x plus delta x raised to the power of n minus x to the n all over delta x. Now let's expand this. The derivative of x to the n with respect to x being equal to the limit or delta x approaching 0, x to the n plus nx to the n minus 1 times delta x plus n times n minus 1 over 2 times 1 times x to the n minus 2 times delta x squared plus many more terms of delta x increasing in power, the last term being delta x to the power of n. This all being subtracted by x to the n, and the whole numerator is divided by delta x. The x to the n terms cancel out, and now we need to divide the numerator by the denominator. We write the derivative of x to the n with respect to x being equal to, for the limit of delta x approaching 0, nx to the n minus 1 times 1 plus n times n minus 1 over 2 times x to the n minus 2 times delta x plus many more terms of delta x increasing in power, the last term being delta x to the power of n minus 1. However, this is for delta x approaching 0. So every term with delta x in it becomes 0. So this all approaches 0. Now we're left with the derivative of x to the n with respect to x being equal to nx to the n minus 1. with this, we can now find the derivative of any polynomial function. We'd write it as the derivative of cx to the n with respect to x. This is assuming we know the product rule, being equal to cnx to the n minus 1. Let's use a very basic example. 16x. So the derivative of 16x squared over delta x is equal to 2 times 16, so 32, 2 minus 1, 1. And so we have 32x to the 1, or just 32x. While we proved the power rule with integer values of n, it also works with non-integer values of n. Thank you for watching.